All right, hope everybody's doing well. This is a 26-inch Samsung monitor, computer type monitor, and it was brought to me by a teacher, and it's a model number UN26D4003BD. That's the model number right there. And what it was doing was, when you turned it on, or when you plugged it in, the little light at the front of the monitor that indicates whether it's in standby was just blinking, 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 blinking. Anyway, so I told the teacher, I said, hey, bring it in. I'm in my electronics class here at Edinburgh North High School, AC/DC electronics. I've been kind of showing the students, hey, you can kind of learn how to repair stuff. And so what I did was, he brought it in, and I tore into it, and this cap right here, it's hard to see, but what starts happening to the caps is they dry out, and this one's like almost popping out. It's hard to see that. It should be very flat like this one, and it's not. You can see it's kind of coming out. And so this is the whole power supply. That's the video section right there. And then there's a remote. I want to say this goes to the remote section. And so I told him, I said, look, we need to replace this guy, this guy, this guy. These are all the capacitors. That one, and then there's one more over here. Now the issue you'll have is you definitely have to get the diameter and the actual length. Specifically on these guys right here, this one and that one. And this one can be a little bit bigger in diameter, and maybe smaller, but definitely you got to get why, because it's a very slim back. That's the back right there. It's very slim. And so, I told the teacher, I said, look, I don't think these parts are going to cost more than, I don't know, $20-$30 maybe. He's I don't know if he's already bought another one, and he was just using this to look at his video cameras from his house and stuff. So anyway, I'll show the kids, the students. I'll take this out, unplug this guy, unplug that one, pull this whole thing out, and I have a soldering station here that the school bought many years ago when I used to teach soldering, desoldering, and all that. And hopefully I can get some videos of that. And it's just going to Moser, Arrow, or one of those Arrow Electronics, whatever. I'm going to try and find those. Let him know how much it's going to cost, and then he'll decide yay or nay. I'm thinking about just paying it for myself, and even if he doesn't, just to get it fixed, just to show the students, hey, look, you can do this. So anyway, again, this is, just showing how to repair this. Basically, if you were to take this into Best Buy or someone like that who repairs it, they would just replace this entire piece right here. The problem is that this monitor, you could probably pick it up for 150, maybe 160 bucks, and this whole power board here is going to run you 75 bucks, maybe 80, and then they're going to charge you another $50. So man, you're into it 130, 140. You might, at that point, hey, you know what? I'll just buy a new one. But again, like I've said in other videos, I'm old-fashioned. I tell my students, hey, look, I used to do this for a living. I used to repair home and car audio and stuff, and if you can repair it and keep it out of the landfill, I think it's a good deed we can do. So anyway, hopefully, when I'm soldering whatever, I'll show some video. All right, see you guys later. Bye. Okay, so here we have this power supply from a Samsung monitor that showing my students how to repair at the component level. We've already got this component loose, and we've already taken out this guy right here, and it went right here. This guy went right here. And so I'm going to show just quickly how we do that. And so you definitely have to have some type of soldering. I know this is a really nice setup. This is about $7,000 from Pace, and it comes with a this wand here. It's a solder sucker, and it has a hole. The tip of it. See, I'll grab one here, and y'all can see it better. The tip of it has. See, I'm hoping this will focus. It has a hole in the middle of it there, and it heats up. And then it's got the unit here has this suction, and this, when you press this, it sucks through the center of the tip there, and it sucks out the solder. So we see if I can grab this a little bit better. There you go. Okay, so we're going to try and get this one out right here. So what happens is you put it in the lead into the, and then you press on it, and it's already, so now I press it, and it's removed the solder. Okay? Right. Pretty much like that. Now, if you don't have this unit, I know $6,000, $7,000 is a lot of money. Then what you do is you take your typical iron, and you use this braid, which is that guy right there. That's the braid, and you put the braid up. You're holding the braid up against one side of the lead here, and then you press the soldering iron against the braid against this, and the solder will wick into the braid. Okay, so that's another way to take out solder. And then there's another way. It's called a solder sucker, and I don't have one out. But, anyway, so this capacitor, this capacitor for sure is bad. We're replacing all these. This guy, and that guy. I've already ordered them. So we're hoping that it's going to fix it. I think that the parts were like $20 with shipping from a place called Moser. Now, how do you check a capacitor? Well, you can check it with a machine like this. This is DEREE DE5000. Now, you do need to know on this one, it's kind of auto ranging. It'll tell you what the capacitance level is, but and then you're looking at the ESR, and in order to know the ESR, you would have to go to the manufacturer of the capacitor. In this case, this is Sam Young, not Samsung. It's Sam Young, and I went to their site, and all they give you is just some tolerances of the capacitance. They don't give you what the what do you call it, the ESR should be, right? So obviously you want the ESR as low as possible. Okay, now this one here, it's this capacitor is at oh god, what was it? It's, I think it's 16 volts at 1,000 microfarads. I don't even know y'all can see that. Come on, there you go. 16 volts at 1,000 microfarads. And I placed it on here, and it's not even close. It's already starting to come undone. The capacitor is coming out. Let's see if I can get it to focus there, but it's that little rubber thing. It's starting to come out, and then, okay, come on, phone, focus. And then that top should be totally flat, but it's already kind of bulging. Anyway, so another way to test it is to have a machine like this one here, which is a Sencor LC102, and this is a capacitor inductor analyzer. And so let me plug. Let's see what we can do. We'll get this guy, and let me see if I can plug this guy in, because it's already set for this one right here, and I'll show you how it works. So we'll do it that way. Let's see, come on. So there's a negative and a positive to this. So we definitely got to get them right. Okay, so now what you do is this is an aluminum lytic capacitor. You then you can short out the leads, and then you do a short test right here. You hold it down, and it kind of takes out any resistance, I'm assuming. And then you do an open. You open up. Don't put anything on the leads, or undo the leads, and then do the open test here. Leave this on ohms. All right. So then what you do is you enter 390 microfarads. I already have the 25 volts, because that's a 25 volts at 390. And now all we're going to do is just press here. See if I can get the glare to not yeah, there. Well, let's see if I can do it from down here. Okay, so I'm going to press it. It's 399 microfarads, which is pretty good. Then I'm going to go to the absorption. You got to hold it, saying it's good. And then we go to the ESR. Okay, saying good. And now to check the leakage, we're going to put this up to their current, and then check the leakage here. And it's 2.24, and it'll tell you whether it's good or bad. Okay, so that's how you do that. Now we can check another one. Well, typically what will happen is when you're checking these, it'll come back and tell you whether it's bad or good. Okay. I told the owner, I said, I'm going to go ahead and just replace all the capacitors. This unit, here's the monitor. It was made back in 2011. So, and he uses it for just monitoring his video around the house, his video cameras. So, anyway. Figure that was a quick attempt. This one, I'd have to set it up, and then come back and show it, because it's kind of hard to connect anything on here. But it works. You like I said, you do need to know from the manufacturer what the ESR is, unfortunately, this company doesn't show that. Other companies that I've checked with this is my personal unit. You go to their site, you look at the the specs, and then you look at the ESR and stuff, and you go from there. All right, I'm gonna stop there. Okay, so here's the the capacitor that we know is bad. It's supposed to be a 16 volt at 1,000 microfarads. I managed to put it on here, and so there's it's 12 microfarads, and then the ESR is extremely high. That's 15.04 ohms, and usually you want it to be a lot less than that. I'm going to say probably in below 4 or 5 ohms. They make some low ESR capacitors, and you're talking like they're at 0.1 or 1, typically less than 2 ohms. So that guy's bad. Excuse me. So this guy does go also through some calibration, and the way you do it is you hold calibration, I think, for 2 seconds. And then it'll tell you open, and so you make sure that there's nothing connected to these guys, and then you press it again, and it goes through 30 seconds of calibrating, and then the next thing it'll come up, it'll say short SRT or something like that. So then you short out the leads, you press it, you short out the leads, and then you press this again, and it'll go through the calibration, and then you're good. And it'll auto calibrate. So let me just turn off the power, and then just turn it back on, and it'll go into auto. All right, now to see the ESR, it's this button, but right now it won't let you go into because it's on D. So let me try it. See, and it just beeps. So what you do is, what I found is you click this guy, you click it again until it goes back to that, and now you can see, you can change, and there's the ESR, and then this is, I can't remember what the D stands for. Q is the quality, and then ESR is right there. There you go. So, so that's how you use this. Again, you do need to know what the ESR is for the capacitor. And like I said, some companies, this company doesn't give you that. Other companies do, and you can go and you know, typically it's on a PDF. You can download it. At home, what I have is I have a manual. Or actually, I have several different companies that have of capacitors that I mess around with, and I have them in a binder, and I just go there and I look and stuff. And if it's a new one, if it ain't there, I just go back to the company and they'll have updated their database. So that's how you use that. Okay. Now, another way to check to see if a capacitor is, you know, you'd have to see where that capacitor is, what it's filtering. If it's filtering a 5 volt or a 28 volt or whatever power supply it's filtering, and then you would have to have an oscilloscope and then you know, measure any AC ripple. Really on DC, you don't want to have any AC ripple. If you're measuring DC with an oscilloscope and you have AC ripple, more than likely the filter caps are probably bad in that section. So, alrighty, we'll talk to y'all later. All right, so here is the monitor that I repaired, and it's working just fine. It's a DVD playing there. So the owner's real happy. Total parts, cost and parts, tax and shipping was like $19 or something like that. So, all right, at least this is not going into the landfill and being crushed or recycled. He can still use it to view his surveillance cameras at his house. All right, we'll see you. Have a good one.